Okay, good morning, guys. Assalamu alaikum. Welcome back to grade 12 maths by Inspired Teens, where in today's lesson we are going to be continuing with trigonometry. Okay, before we continue, I'd just like to confirm, can you guys hear me? Can you guys see my screen? Is it clear? Okay, that's fine, as long as you guys can see me. Please, throughout the lesson, if my screen becomes a bit blurry, please let me know and then I'll fix it. But for now, I think it's okay. Okay, so just to recap what we have done, what we did last week, we went through the basics, okay, basic cast diagram, understanding which trigonometric ratios are positive in which quadrant, okay, on a Cartesian plane, and we did reduction, okay. So we did regular reduction. We did the few rules that are included in the reduction: 90 to 70, negative angles, angles larger than 360, squared trig ratios, and so on. Okay, and today what we're going to do is and then we also did these examples from past papers. Okay, and today we're going to continue on. Okay, we're going to do these reciprocals, special angles, Cartesian plane questions in terms of questions. Okay, that's most likely what we're going to be doing. Okay, let's have a look at this, the reciprocals. Okay, so by grade 12, it's not used as often as it was maybe used in like grade 10 or 11, but it's good to know it just in case as well. All right, so the reciprocals, okay, of our trig functions is 1 over sine. Okay, we have 1 over sine, 1 over cos, and 1 over tan. So 1 over sine theta is equal to cosec theta. Okay, and 1 over cos theta is equal to sec theta, and 1 over tangent theta is equal to cot theta. Okay, so while sine theta, okay, is equal to opposite over hypotenuse, okay, cosec theta, which is its reciprocal, would be equal to hypotenuse over opposite. It's 1 over 8, so it flips. Okay, this is what we call the reciprocal of sine. Okay, then we have cos theta. So if cos theta is adjacent over hypotenuse, okay, then sec theta, which is the reciprocal of cos theta, is hypotenuse over adjacent, right? And then if we had tangent theta would be equal to TOA, opposite over adjacent, and since its reciprocal is cot theta would be equal to adjacent over opposite. Okay, so you can see how we just flip it over to get our ratios for sine, cos, and tan. Okay, so yes, those are the reciprocals. Please make sure to know those. Okay, let's have a look at special angles. Okay, so special angles, right, they are important. Technically, you could just use your calculator to solve them, but there are certain questions where they tell you to not use your calculator, and in those specific cases, you'd have to know the value of the special angle. Okay, so here we have the special angle triangles, which I have drawn. So many people prefer to learn them by just knowing this triangle. And once you know the triangle, okay, once you know the triangle, one second. And once you know the triangle, then it's easy to get the value of each special angle. Okay, but I'm going to fill in this table. So firstly, we have sine 0, okay, and cos 0 and tangent 0. These are the values, okay? You can think of these with respect to the graphs, okay? So at 0 degrees, sine has a value of 0. At 0 degrees, cos has a value of 1. And at 0, tangent has a value of 0 as well. Then we talk about sine 90. Now, at 90, sine has a value of 1, cos has a value of 0, and tangent is undefined because there's an asymptote at 90 degrees on a tangent graph. Okay, so just keep that in mind. Okay, Then we have, okay, so sine 30, we can turn to this triangle here. Sine 30, so here's 30, we'd have to have opposite over hypotenuse. So opposite over hypotenuse. So sine 30 would become 1 over 2. Okay, then we have sine 45. So we have to go to this triangle, 45, opposite over hypotenuse, which is basically 1 over root 2. Okay, and when you rationalize the denominator, this is equal to root 2 over 2. Sorry. Okay, so that's when you rationalize the denominator. Let's look at sine 60, opposite over hypotenuse, root 3 over 2. Okay, so I'm just going to speed through this. Cos 30, we get a value of root 3 over 2 as well. Cos 45, okay, cos 45, I get a value of 1 over root 2. Cos 60, I get a value of 1 over 2. Tangent 30, 1 over root 3. Tangent 45, we get 1. And tangent 60, we get root 3. Again, we turn to both of these triangles for any of those answers. Okay, if you're confused as to how do we get those answers, we're getting it directly from the triangle. Okay, so just keep that in mind. Okay, cool. So let's move on. They say solve the following without a calculator. Okay, so this is where your knowledge of special angles comes in. So for example, they have tangent 60 plus cot 30. So tangent 60, we know. Tangent 60 is root 3. Okay, then they have cot 30. Now cot 30, okay, is the inverse of tangent. And tangent 30 is 1 over root 3. Now cot 30, if you want to get cot 30, you'd have to flip it. So cot 3 is root 3 over 1. Okay, so you're basically adding root 3 and you're getting an answer of 2 root 3. Okay, let's have a look at this. So don't be afraid by these squares. The way you solve with these squares is you simply get the value of, like, for example, sine 45, and then you square the entire thing. So sine 45 has a value of 1 over root 2. So 1 over root 2, you take it and you square it. Okay, so whatever the value of cos 45 is, you square that value. Then we have, what is this? Cos 30. Cos sine 30 is root 3 over 2. Root 3 over 2. We square it. And basically, that's how we're going to get it. So again, we can't use a calculator here. So we can simplify. When you square a fraction, you square the numerator and denominator. So this becomes 1 over 2, because square root 2 squared is 2, minus 3 over 4. Okay, you want to get them to the same bases, right? You do LCD. This becomes 2 minus 3. This becomes negative 1 over 4 as your final answer. Okay. Hope that makes sense. That's simple, right? Without the calculator, you're basically just substituting in your values for your special angles and then finding the answer. Okay. So let's move on. Okay, actually, quickly, before we continue, I just wanted to identify a quick way of remembering this. So remembering which reciprocal belongs to which trig function, it's always the third letter of the reciprocal that matches the first letter of the actual trig function. So sine, third letter here is cosec, that means it belongs to sine. Third letter of sec is cos, that means it belongs to cos. Okay, then for cot, the third letter of cot is t, that means it belongs to tangent. Okay, so that's just the easier way to remember it. Okay, let's move on to a question. The next question, Cartesian plane and / Pythagoras theorem questions. Okay, so you've seen these questions numerous of times. there's certain steps here that they want us to follow in order to solve it. But let's have a look at the question and understand what the question looks like. Okay, which question are we solving right now? Okay. Okay, so it says, if, this is the question, by the way, if sine theta minus 2 is equal to 0 and tangent theta is less than 0, determine sine squared theta plus cos squared theta without using a calculator and by using a diagram. Okay, so this is the type of question that we can solve. Let's have a look at this one. In the diagram below, A is a point on the Cartesian plane such that AOT, angle AOT, is equal to alpha, with OA equal to 4, P is K and M is such a point that OP is equal to 6 and OA is perpendicular to OP. Okay, so we have this type of diagram with a Cartesian plane. Okay, and basically they don't want us to use a calculator. Excuse me, they want us to use this diagram. Okay, and then they have a bunch of questions to solve. So now I'm sure you guys have seen this type of question, right? I'm sure now maybe it's looking a little bit more familiar. It's the same as grade 11. It's just that in grade 12, of course, they can add the grade 12 identities that you guys need to know. Okay, so this is the type of question that we're going to solve, the Cartesian plane / Pythagoras questions. Okay, and this is how we're going to solve it. So it says the steps: isolate the trig ratio, determine the quadrant, draw a sketch, and use Pythagoras, answer the question. Okay, so let's do it, and then we can go back to those instructions. Okay. So they've given you, if 3 sine theta minus 2 is equal to 0, okay, and tangent theta is less than 0, determine the value of sine squared theta plus cos squared theta without using a calculator and by using a diagram. Our first step is to always isolate the trig ratio. So let's take this equation that we were given. So you utilize the equation that you're given and isolate the trig ratio. Let's do this. Okay, so I have 3 sine theta minus 2 is equal to 0. Isolate the trig ratio means that I should leave it alone. So you can do this in a quick step. I'm just going to take it step by step by taking 2 over to the other side, becomes 0 plus 2, which is 2. Divide both sides by 3. It cancels on the left. I'm left with 2 over 3. Okay, so now I have that sine theta is equal to 2 over 3. Okay, I have that sine theta is equal to 2 over 3. Okay, now just remember, okay, this here is the ratio for sine theta. Sine theta, okay, let's see if we can. Sine theta, okay, is opposite over hypotenuse. Opposite over hypotenuse. So I have the value for opposite and I have the value for hypotenuse. Okay, always keep that in mind. All right, this is going to link us to our Cartesian plane. So let's draw up our Cartesian plane. Okay, so this is how we solve this question, by the way. So sometimes they'll tell you, they won't have to say by using a diagram. They could just say without using a calculator, or they could just say by using a diagram, or they could say both, like in this case, without using a calculator and by using a diagram. But you should know, irrespective of which one they give you, which one they want you to solve it, or how they phrase it rather, you're going to be using a Cartesian plane. Okay, and we're going to be using it in the following way. So since we have the value of opposite of hypotenuse, you would think that we could draw a triangle. Okay, but the problem is we can draw a triangle in every quadrant, right? Which quadrant do we draw a triangle in? Okay, so we're going to draw a triangle in the Cartesian plane, and that's how we're going to solve for this question. Okay, but we cannot just draw that triangle in any quadrant. We have to determine which quadrant it's in. Okay, so again, first step to isolate the trigonometric ratio to basically determine some of the values of your triangle, which is in this case, we determined opposite over hypotenuse. Now we need to draw this triangle and we need to determine which quadrant in our Cartesian plane we're going to draw this triangle in. So for that, we can use two things. The first thing we use is this. Actually, the first thing we use is this. The fact that we have positive sign it's a positive. Let's try and make space for that. Okay, it's positive sign sine theta. So since sine is positive, we can understand which quadrant is sine positive in. We draw our cast diagram. Okay, since sine is positive, we need to choose the quadrants in which sine are positive, which is first and second. Okay, so in the first and second quadrants, sine is positive. Okay, so that actually guides us. That tells us now which one are we going to draw it in. So this gives us two options. We can either draw it in the first or the second. And we cannot just decide off this. We need a solid, we just need one answer as to where we're going to draw it in. And that's where this comes in. Sorry. That's where this comes in. That's why they give you the additional criteria here. That tangent theta is less than 0. So the first way we determine it is by seeing our trig ratio that we isolated. Is it positive or negative? If it's positive, the screen is blurry. Okay. Thank you for letting me know. I'm going to reshare in a second and it should be fine. Okay, that should be a whole lot better. Let us continue. Okay, so we said the first way to determine which quadrant we are in is by analyzing the trigonometric ratio that we left alone. Okay, we analyze, okay, this trigonometric ratio, is it positive or negative? If it's positive, you choose the two quadrants which it's positive in. If it's negative, you choose the two quadrants that it's negative in, right? But then we need to narrow it down to one quadrant, and that's where this comes in. This one says tangent needs to be negative. Now, if you look at your, okay, let's throw another one here. Just let me know if it's better. Okay. Where is tan positive? Tan is positive there and there, so therefore it's negative here and here. So tan is positive, tan is negative in the second quadrant and in the fourth quadrant. Okay, so tan is negative in the second and fourth quadrant. So now this here is indicating to me that the quadrant we should work in is the second or first, but this one here is indicating it should be second or fourth. So the common one between the two is, of course, the second. Okay, so remember, our first options were first or second, and then tangent needed to be negative. So tangent is only negative. Out of these two, tangent is only negative in the second. So therefore, we choose the second. I hope that makes sense. Please, if you have any questions, let me know. I'll revise it one more time. So firstly, we isolate the trig ratio. Isolate the trig ratio, get a value, get an actual ratio for that trig function. Okay, in this case, we got 2/3, and it is a positive value, so we knew that we were going to draw in this first or second quadrants. We go to the specific condition that's given, that tangent theta needs to be negative or less than 0, and we chose the less than 0 ones here, second or fourth, and the one that's common between the two, they sort of narrow it down to one quadrant for you, so that says second quadrant. Okay, now we're going to actually draw it. Okay, so let us draw it, and drawing it is important, right? So we're going to draw it in this quadrant, which is our second quadrant. So the first thing I'm going to draw is, let's use, hello. I'm going to draw it. I'm going to draw my hypotenuse. So this is the method you will always follow, right? You're not going to just draw it like here. I need random triangle. That's definitely not a triangle. You're not going to just draw it. That's also not a triangle. Never mind. Okay, you're not going to just draw it here. You always start from your origin, and this is going to turn out to be your hypotenuse. You draw in your hypotenuse, and then you complete it down always to the x-axis. You complete it down always to the x-axis. Okay, so that's how you draw your Cartesian plane. So if we were in the first quadrant, let's not do that. We would draw hypotenuse and down to the x-axis. If we're at the bottom, hypotenuse and up to the x-axis, always to the x-axis. Same if we were in the fourth quadrant, we would draw to the x-axis like that. Okay, so just keep that in mind. Here we're drawing strictly in the second quadrant. Now we can fill in values. Okay, so we're going to call this. So a lot of the times you'll see this be called theta. Okay, don't let it confuse you. Okay, basically you're always working with this part of that of the theta angle that's in the triangle. So you're always working with this angle here. Okay, so don't be confused by when they say that's theta, that's fine. Okay, treat it as if this was theta in the triangle. Okay, so in this case, that's theta. We know the value of opposite and hypotenuse. Okay, so opposite is this blue line, and the value of opposite is 2. Hypotenuse is this red line, and the value of hypotenuse is 3. Okay, so now that we have opposite, we have hypotenuse, we can determine adjacent. So we always want to complete the triangle, right? Fill it in, always. Complete the triangle, fill it in, get the value of the adjacent. So how do we do that? Using Pythag. Remember that Pythag is hypotenuse squared is equal to opposite squared plus adjacent squared. And in this case, we don't have adjacent. And when you leave adjacent alone, this is what your equation looks like. Adjacent is the square root of hypotenuse squared minus opposite squared. Okay, so in our case, it's equal to adjacent is equal to square root. Hypotenuse squared is 3 squared minus 2 squared. Okay, that's correct. I believe in the adjacent here, you get a value of square root 5. So this black line along the x-axis, its value is square root 5. We used Pythag to calculate that. Okay, so now we've completed the triangle. Always do that, always complete the triangle. So we've isolated the trig ratio. We've determined which quadrant we draw it in, and we drew a sketch, and we used Pythagoras, right, to solve for the third side. Okay, now what's left to do? Answer the question. So basically that thing that they want us to solve for, which is this pink thing, determine sine squared theta plus cos squared theta. Okay, so we take it in, we have sine squared theta plus cos squared theta. Okay, now the values of sine theta and cos theta that we're going to get using what we just drew, our Cartesian plane. So sine theta, sine is opposite over hypotenuse, opposite is 2, hypotenuse is 3, that's the value of sine theta. So this is equal to 2 over 3, remember it's squared, so we square the whole thing, plus cos squared theta. So remember cos is adjacent over hypotenuse, so here's theta here, adjacent over hypotenuse. So this is square root 5 over 3 whole squared. Let's simplify. This becomes 4. Remember, you square each term in the fraction, the numerator and denominator. This becomes 4 over 9 plus 5 over 9. This becomes 9 over 9, which is 1. And that's our final answer, just 1. Okay, if you guys have any questions, please ask me, but that's how you solve this Cartesian plane question. Let's solve the next one. Okay, so in the diagram below, A is a point on the Cartesian plane such that angle AOT is equal to alpha, with AOA equal 4, P is equal to KM, is a point such that OP is equal to 6 and OA is perpendicular to OP. So none of that means anything without actually having a diagram. So our job, remember, always is to read whatever is the explanation and make sure that whatever's in the explanation is also in the diagram, right? So that we can only use the diagram and we solve using the diagram. Okay, so AOT is equal to alpha, that's there. OA is equal to 4, that's written. OP is equal to 6, that's written. OA is perpendicular to OP, that's also given. Okay, and then KM, and then that's actually, this is extra information for A. It's given as B and 1. Okay, determine the value of B. Okay, so just not to confuse you. So what's happening here is we are working with two triangles. Okay. The first of which is, I think it's supposed to be going till T. Okay. The first of which is this one that goes to T. Okay. And then the second one is this one here. So remember, we always draw our triangles. So let me just highlight it. It's this one here and this one here. Okay. So remember, we always draw our triangles in one way. Okay. We draw our diagonal line from origin, which is the hypotenuse line. Okay. And then we take it down or up to the x-axis. Always complete the triangle to the x-axis. Right. And then the x-axis itself would be the other line of the triangle here. Here. Okay. So yes. So what's going on here, okay, is that we are working with two triangles. Okay. Now, before we continue, I don't know if we did. I just want to revise this that we went through in the first lesson. Okay. Discussing on a Cartesian plane. Okay. And I want to give one more extra piece of information here. So if you want to memorize this, you're more than welcome to. Okay, however, you don't have to. You can still use your understanding of opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. These are just now given in terms of the Cartesian plane, y values, x values. Okay, like a coordinate, literally. Okay, that's why they're given as y, x, and r. R is our hypotenuse. Okay, this guy here. Now, the thing to note is this value here, this is the x value, okay? Because if you have to think of it, this would maybe be, if that's 5, for example, that would be the x coordinate there. It would be 5. And because it's from origin, which starts here, right? The origin is 0. This is 5, okay? Now, in this case, we have a distance of 5. Okay, so this value, the distance of this line actually gives us the x coordinate of this point here, which is 5. Okay, and this distance here, okay, which is the opposite of theta. So the opposite of theta, right? Remember, if we start here from y, where y is a value of 0, if we go all the way up to that point, okay, where perhaps y has a value of 4, then like attached to the y-axis, by the way, 4. Okay, then we know since it starts from origin, this distance is actually 4. So this distance here is the y coordinate at this point here. Okay, and then we have the coordinates of this guy here. Okay, let's call it point A, and this point has coordinates, an x and a y coordinate. Now, the x coordinate will basically always follow adjacent, okay, or whatever this x value is, or the easy way to remember it is the x-axis, okay? The x coordinate is going to be the value on the x-axis. And in this case, we said, let's say 5, okay? And, okay, let's just say this coordinate is always x and y. In our case, it's 5. And we're talking about this coordinate here, by the way. And the y coordinate, it went how many up? It went 4 up. So the y coordinate is 4. Okay, and if you want to remember it, it's the y coordinate of that point, specific point, is the value of the line that's parallel to the y-axis. Okay, which would be the opposite line here, the one highlighted in blue. Okay, so that's quite simple. You just need to remember it and understand it completely. This is this what do you call it? This coordinate here. Okay, and the easiest way I like to remember it is this one. The x coordinate comes from the x-axis, and then obviously the other one comes from that one. Okay, so just keep that in mind. So let us continue with our question. Okay, in the diagram below. Okay, cool. So some important things to note. There's all the information that's in the written is in the diagram, so I'm gonna ignore that for now. They want us to determine the value of B. So just be, like I said, be careful. We are working with how many triangles? 2 different triangles. Okay, so I identify B and which triangle it's in, and then work with that specific triangle. Just keep in mind, okay, that this angle, this angle here, yeah, okay, works with this triangle here. Okay, we're working with that little triangle inside of the, that little angle inside of the triangle. Okay, whereas here, this is not given any variable, the angle for this triangle. We're working with that angle there. Okay, that triangle. So just keep that in mind. Okay, always from 0 to wherever the triangle is. Okay, cool. So now how are we going to determine the value of B? So if B is firstly here in this triangle. Okay, in this triangle, we are given that OA is 4. So I just want to move it a little bit. And I'm going to make it red. Yeah, that's a red line. That's just probably a bad idea. Let's use blue. Okay, so now it's all different lines, so you can refer to them as colors. So in this case, okay, this was given as 4, by the way. This was given. I just rewrote it. Here's it here. Okay, so it's given as 4. Now we have to use this information of A, which is, by the way, this coordinate here. We have to use that information, okay, to try and do what? To try to fill in this triangle. So we have B and we have 1. So remember, this is an X and a Y. And we just learned that the X is always the value on the X coordinate. So this here we can call B for now. This distance we can call B. And then the Y-axis would always be the vertical line of the triangle, the one's parallel to the Y-axis. So this is 1. Okay, so now we actually have 2 values in a perpendicular triangle, always 90 degrees. Okay, we have 2 values in a perpendicular triangle, okay, which then results in us being able to use Pythagoras. Okay, I'm going to do it quickly. Adjacent is equal to the hypotenuse squared, which is 4 squared, minus the opposite squared, which is 1 squared. This becomes 16 minus 1, which is 15. Can we simplify 15 more? I think that should be fine. Okay, so the adjacent is square root 15. So the value of B is actually, why is it B? Because we used Pythag, and this value is actually square root 15. Okay, determine the value of B. This is how we do it, but it comes from the understanding of what B is. B is the x coordinate of this point here, okay, and the x coordinate of that point there. We can we can get that by knowing the values of the sides in our triangle, and we also know that this is 1. We know that it's the pink line because it's the y coordinate, so that means the vertical line is 1, and this is B, which is unknown, the x-axis, which is the x coordinate here. And we can use Pythag to solve for it because we have the value of 2 sides, and then we can get the value of the third. So now we have all values in here. So remember, this is represented by alpha. Okay, it's represented by alpha. So we can get the value of sine alpha, cos alpha, tan alpha. Okay, so B, okay, cool. Determine, without the use of a calculator, the value of tangent alpha. So remember, I just said we can get this, right? Excuse me. So tangent alpha, we turn to our little diagram. Here's alpha here. Tangent is TOA, opposite over adjacent. Opposite is 1. Adjacent is root 15. This is going to be 1 over root 15. They probably won't want you to rationalize it, but when you do rationalize it, you get root 15 over 15. Let's look at B. Sine negative alpha minus 180 plus cos negative alpha. So before we can get an answer for cos alpha, sine alpha, and before we can use our diagram, in this case, we actually have to reduce. But remember, when it comes to reduction, you cannot have a negative angle. Okay, so remember the shortcut. We change it. Okay, we make this positive, and we change both signs basically. So this becomes positive in this case. We actually didn't do a specific example like this, but both signs become opposite. Right? We did one where it was just alpha minus 180, and then it became 180 minus alpha. Here, it's going to become positive alpha, positive 180. So that's fine. Right? So we can simplify this to sine 180, positive 180, positive alpha. Plus, then we have cos negative alpha. That doesn't change because remember, cos swallows that negative. So this is the same as writing cos alpha. Okay, now we can reduce. Okay, let's use cast. So sine 180 plus alpha. 180 plus is in tangents quadrant. Sine is negative. This becomes negative sine alpha plus cos alpha. Now we can utilize our triangle and substitute values from there into here. So sine alpha, sine is opposite over hypotenuse. So it's going to be negative 1 over 4 plus cos alpha, adjacent over hypotenuse, which is going to be root 15 over 4. Okay, this results in what answer? Oh, I did something wrong. Hold up. Rather, I forgot something. Okay, so remember when we change this, we have to actually make the front negative. I forgot about that. Okay, because remember, you're taking a negative common bracket, and then sign doesn't swallow the negative, it takes the negative outside. Okay, so just keep that in mind. Oh, and I'm forgetting another thing. Yeah, even here. Okay, excuse me. Okay, let's just go back here and revise one more thing that I forgot to tell you guys about, or remind you guys about. And that's the fact that we're working with the Cartesian plane. And how does it affect our values? Okay, because remember, a Cartesian plane has negative and positive values of, it has negative and positive values of x and negative and positive values of y. So the important thing here to understand is which side on the x-axis are you and which side on the y-axis are you? Basically, should I have a positive y value or should I have a negative y value, or should I have a positive or negative x value? Okay, so let's look at this here. The first thing you need to note is that your hypotenuse will always be positive. Hypotenuse always positive. Now let's consider the y value. The y value, we can clearly see we're above the x-axis. So this is where y values are positive. So this too should remain positive, right? That makes sense. However, the x value, that's what is different, because remember, here's my y-axis, here's my x-axis. On my negative side, here I have negative x values. And here I have positive x values. So the root 15 is on the negative side where the negative x values are. So this should be negative. It should be negative. And this here inside here should be negative. It won't affect our answer because we square it. And ultimately it becomes positive, but that's what we need to keep in mind. Okay, it should be negative. Okay, I hope that makes sense. Again, if you guys are confused or if you have any questions, please ask me and I will get to your query. Okay, cool. Let's move on. So we need to make the same adjustment here. This should be negative 15. Negative root 15. Okay, because it's on the negative, it's on the side of the Cartesian plane where we have negative x values. Okay, so now let's solve from here. So again, we have negative sine 180 plus alpha plus cos alpha. So negative sine 180 plus alpha. So remember, what did we say? We said that 180 plus alpha, sine is negative. So this actually becomes negative sine alpha. Okay, obviously a negative and a negative make a positive. So it's just positive sine alpha. Cos alpha, now that's going to change. You see how the answer changes? cos alpha is adjacent over hypotenuse, so negative root 15 over 4. This becomes negative root 15 over 4. Let's simplify sine alpha as well. Sine alpha is opposite over hypotenuse, so 1 over 4. So 1 over 4 minus root 15 over 4. Simplify this all under one fraction. It basically becomes 1 minus root 15 all over 4. And that's your final answer. 1 minus root 15 all over 4. Okay, I hope that makes sense. And I hope the recap of this made sense as well. Okay, and understanding why it's negative. Okay, so let's just do a quick example. Let's just say we're here and we have this triangle. Okay, let's just say this is theta. We're working with this angle. In this case, right, we would have a negative y value, but a positive x value. Okay, like a positive root 15, because look, we're on the right hand side of the y-axis. This is where x values are positive. But here we are below the x-axis where y values are negative. So that's why we'd have a negative value. So just keep that in mind. Let's solve this last question. Without the use of a calculator, determine the values of k and m. Okay, so k and m are in this triangle here. Let's do this. Okay, so k and m are in this triangle, okay, and we know the value of the hypotenuse. Okay, I'm just gonna write nice. It's given as 6. Okay, so this value, please, it's given here. Here's it given here. Okay, it's given as 6. Now we have these in terms of variables. So p, right? We have k and m. Okay, so remember k is the x value, so this would be k and this would be m. Okay, now we cannot use Pythagoras because we don't have two knowns, right? We have two unknowns and only one side is known. Okay, so we cannot use Pythagoras. Okay, so for 5 marks in this triangle, we don't have any values to work with. How do we solve for it? How do we solve for it? Okay, so now this is where this tricky bit comes in. We have to actually try and relate alpha, the triangle where we know information. We have to try and relate that triangle to this triangle, which we don't know any information about. So we're trying to link this triangle to this triangle. Okay, so if you look at it, right, this angle, which is inside of this triangle, which we're trying to solve with now, okay, is 90 degrees less than alpha. Or let's call this theta, right? Alpha is 90 degrees more than theta because there's a 90 degree that separates it. So alpha plus a 90, sorry, theta plus 90 would give me alpha. And that's exactly how we're going to solve it. So we're going to represent theta. Theta is equal to alpha minus 90. Theta is equal to alpha minus 90. Okay, so now instead of theta, we're going to write alpha. Okay, and I'm going to show you why that makes sense. Let's copy this and bring it down. So theta is equal to alpha minus 90, and that's the key to solving this question. Okay, it is to understand, relate the two angles to one another. So sometimes it might not be related to 90-degree angles. Sometimes it could be, you could relate them to 180. Okay, 180 or 90 mostly. Okay, so now let's continue. Okay, so this question is slightly more complex because it's 5 marks, right? So let us try and express and let us do a trigonometric expression using theta. That's not fun. Okay, so I'm going to say sine theta, it should be equal to m over 6. Okay, so sine theta should be equal to m over 6. But now instead of writing theta, I don't have any other values that's going to help me solve in theta. right? Theta, currently that triangle is done. There's not more that can be solved. However, I do have the entire angle for alpha, all the sides in the triangle where alpha is, all right? So that's why I try and relate theta to alpha. So instead of writing theta, I write sine alpha minus 90, okay? And this is equal to m over 6, okay? Now, I can reduce this, theta minus 90, I think that's correct, theta minus 90, but before I reduce, I cannot have a negative reduction angle, so I follow the rule that we know. I make it negative sine, and I flip the 2 inside, 90 degrees minus alpha. And this is still equal to m over 6. Now, 90 degrees minus alpha, that can be reduced. 90 minus, all are positive, so it just becomes negative sine alpha is equal to m over 6. Now, finally, sine alpha, okay, I've expressed theta in terms of alpha, reduced alpha to get sine alpha, okay? And that's where I could use this triangle, okay? So here's alpha here, and sine alpha is opposite over hypotenuse. It's 1 over 4. So here, this is negative 1 over 4, which is equal to m over 6. Now I can cross multiply, okay? And I will get, what will I get? 6 is equal to, negative 6 is equal to 4m. Let's actually flip that around. I would prefer to flip it around. Divide both sides by 4, and I get m is equal to negative 6 over 4, which is negative 3 over 2. Okay, so we've solved for, I do this wrong. No. Yes, I did do this wrong. Sorry. Sine theta is m over 6. No, that's correct. Yeah, sorry. I don't know what I want. Wait, no. Oh, man, I'm making too many silly mistakes today. Sorry, I did my reduction incorrectly because I forgot the main thing. Okay. Yes, it's sine and 90. So this should become negative cos alpha, which is then equal to m over 6. Cos alpha is adjacent over hypotenuse, so negative root 15 over 4. So it's negative, actually, negative root 15 over 4, so they'll cancel each other out. This is equal to m over 6. Okay, when you cross multiply, so let's just, this cancels, cross multiply. Let's just cross multiply. We have 4m is equal to 6 square root 15. Divide both sides by 4. We have m is equal to 6 square root 15 over 4. Okay, so that's your answer for m. So determine m. M is done. So we used the sine theta to solve for m because it was opposite to theta. Now we can use cos theta to solve for k because it's adjacent to theta. So I'm going to do this quickly. Cos theta, okay, this is equal to k over 6, adjacent over hypotenuse. Cos theta, we can write it as alpha minus 90. Remember with cos, we can take the negative bracket and flip these two, but cos will swallow that negative. So this is the same as writing cos 90 minus alpha is equal to k over 6. Okay, now cos 90 minus alpha, that can be reduced to positive sine alpha because 90 minus cos is positive, but then because it's cos 90, we swap it to sine, and then we have sine alpha, which is 1 over 4. 1 over 4, sorry, 1 over 4 is equal to k over 6. Cross multiply, we get 4k is equal to 6. K is equal to 6 over 4. k is equal to 3/2. Okay, so I hope that makes sense. And yeah, we solved that question, right? We solved two types of questions. So please, as we're doing these topics, I would recommend you go ahead and you practice those type of questions. Go to more past papers, right? Remember, there's the link for the past papers in our group. Go through to more of them and practice them. Okay, cool. But yeah, let us end it there. Thank you guys so much for joining. I hope that you guys understood. Please, if you guys do have any questions further, pop me a message and I will try my best to get back to you. But other than that, I will see you guys next week, where we will continue with trig. Jazakallah khair. Assalamu alaikum.